1.2, we are going to be writing rational numbers as decimals. This first section is writing rational numbers as terminating decimals using long division. A terminal decimal is a decimal that stops. It has an end. Terminating itself means to stop. It has an end. For example, 1.56 is a terminating decimal. Not a terminating decimal would be 5.2369 ... That is not a terminating decimal. Okay? Let's look at the first section where it says examples. For example, we've learned to write things like 3/10 as a decimal, 3 in the tenths place, or we've learned to write 21/100 as 21/100ths. So the last digit we use here is in the hundredths place. We've also learned with thousandths, for example, 5 and 323/1000. We can write that as 5, our whole number, 0.323/1000. This last one is in the thousandths place. This last one's in the hundredth place. This last one is in the tenth place. Now, any rational number can be written in decimal form using long division. We're not going to be using calculators now. Later in the future, you'll learn to write these with calculators. So let's write the fraction 1/4 as a decimal using long division. Because 1 is over 4, you could also write that as 1 divided by 4. Fractions is another way in math that we write divided by. So 1 divided by 4. Let's try that with long division. 4 outside and 1 inside. 4 does not go into 1, for we have a 0, so let's add a decimal place, and you need to add another 0. 4 goes into 10 how many times? 2. We take 2 times 4, that equals 8. Let's subtract. 10 minus 8 is 2. Now 4 will also not go into 2, so we need to add another 0, carry it down. 4 goes into 20 exactly 5 times. 5 times 4 is 20. We get 0 as our remainder, and then we could equate the fraction 1/4 equals 0.25, and that is our decimal. Now, after long division ends, we have a remainder of 0 because it is a terminating decimal. With a non-terminating decimal, you would have to keep adding zeros because you would never end up with a 0 down here. You'd have to keep going. So let's try an example. This is example 5. Here we go. A. 3/8. Let's use long division. It could also be written as 3 divided by 8. So we are going to put 3 on the inside. It's divided by 8, so we put that on the outside. Will 8 go into 3? No. Let's add a decimal place. 0. Will it go into 30? Yes. 3 times 8 is 24. We end up with 6. Will 8 go into 6? No. So we need to add another 0. Carry it down. How many times does 8 go into 60? 7. 7 times 8 is 56. 60 minus 56 is 4. Will 8 go into 4? No. Let's carry down another 0. 8 goes into 40 exactly 5 times. We get 40 and ended with a 0. We know that our fraction is terminated. So 3/8 equals 0.375. Now let's try B. In B, we can see 6 and 2 over 25. For this one, we already know the whole number of 6. So we have 6, but as our decimal, we're going to have to add 2 divided by 25. So let's go ahead and write that out in long division. We have 25 on the outside, 2 on the inside. Will 25 go into 2? No, that's a 0. Will 25 go into 20? No, we also put 0. Add another 0. Will 25 go into 200? Yes, it will go into 200 8 times. 8 times 25 is 200. We get a remainder of 0. Therefore, in our equation here, we have 6 plus this number here, which is 0.08. When we add those together, it's 6.08. And that is how we write 6 and 2/25 in decimal form. Go ahead and pause now and do guided practice 1, 2, 3, and 4. Moving on to the next page, we are going to be writing rational numbers as repeating decimals using long division. Remember, as before, a terminating decimal stops. It has an end. Not terminating does not stop. It's repeating. So it is not random like this. It is going to repeat the same number over and over again. For example, 0.333 ... And how we write this is 0.3 with a line over the top. In our examples today, this is how they write it. So let's try the problem that it shows us. We're going to write the fraction 1/3 as a decimal using long division. How we do this is 1 divided by 3. So let's do 1 divided by 3. Will 3 go into 1? No, we need another 0. 3 goes into 10 3 times. 3 times 3 is 9. We get 1, carry down a 0. 3 goes into 10 another time. And 3 times 3 is 10. Oh no, 3 times 3 is 9, I'm sorry. 9. And then we get 1. We add another 0, carry it down. 3 goes into 10 3 times. It's 9. We get 1. It keeps going. By the time you get at least 3 of these repeating decimals, we would say that this is a repeating number. So we're going to write 1/3 as 0.333 ... just like you see up here. This process where it's repeating is called a repeating decimal. Let's try example number 6. Write each rational number as a repeating decimal. For A, it says to use long division. 1 over 11 equals 1 divided by 11. Therefore, we will write this as 1 divided by 11. 11 does not go into 1, therefore we need to add a 0. 11 does not go into 10, so let's add another 0. 11 goes into 100 9 times. 9 times 11 is 99. We get 1 left over. Now let's add a 0, carry it down. Does 11 go into 10? No, we need to add a 0. Let's add another 0. There we go. Does it go into 100? Yes, 9 times. 9 times 11 is 99. We get 1. Does 11 go into 1? No, we need to add another 0. Carry down the 0. And we would continue on. 9, 0, 9, 0, 9, 0, because the pattern would keep repeating. Therefore, 1 over 11 equals 0.0909, or we could write it as 0.09, repeating. Just like we could write this one as 0.3, repeating. Okay? B. Let's try B together. B is also long division. It is 13 divided by 12. We're going to go ahead and say 13 divided by 12. So in here, we will say 13 and 12. Does 12 go into 13? Yes, 1 time. 1 times 12 is 12. We get 1 left over. We need to carry down our 0. Does 12 go into 10? No. So let's add another 0, carry it down. Does 12 go into 100? Yes. How many times does it go into 100? 8. 8 times 12 is 96. We get 4 left over. Let's carry down another 0. How many times does 12 go into 40? 3 times. 3 times 12 is 36. We get 4 left over. Let's carry down another 0. 12 goes into 40. 3 times. We would say 36. The answer is 4. This 3 here is going to keep repeating. So our answer is going to be, oops, excuse me. It's right up here. 13 twelfths equals 1.083 well, 33 or we could write it as 1.083 repeating. Okay, letters C and D, we just need to put in the calculator. So in the calculator we type in 82 divided by 333, and it equals 0.246246 or 0.246 repeating. D, we do the same thing. 2 divided by 7 is what you type into the calculator, equals 0.28571 28571 or 0.28571 repeating. So as you can see, we can either get just one number repeating, like we have up here, or we can get many numbers repeating, as you see down here. Go ahead and try guided practice 5, 6, 7, and 8. Pause the video and do these guided practice now. Okay, last one for today. We are going to be writing repeated decimals using bar notation. As you can see, throughout the lesson I've already been showing you how to write the bar notation. So this section should be easy. For each repeating number that you see, or each set of repeating numbers, you simply draw the line over them. So when it says 0.246 0.246 dot 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 dot. You can write that as 0.246 repeating. Down here, let's try 0.285714, 285,714 dot 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 dot. As you can see, we already did this one up here. So it equals 0.285714. Repeating, draw the line over all the numbers that are repeating. If it is a number such as this, where only the 3 is repeating, and the 0.8 does not repeat, you only draw the line over the 3. Now go ahead and try guided practice 9 and 10. And that is all for today. Make sure you bring your computer tomorrow to class so that we can try the technology activity together. I will see you in class. Have a good rest of your night.